Today's lesson is on finding the interquartile range for a set of data. So before we start working them out, we're going to have a wee look at the words interquartile range and see if we can figure out what it's going to be asking us to do. So inter means between. We already know from the previous lesson that quartiles are three values that split our data into four equal parts. And we know already that the range is the highest number, take away the lowest. So very simply, the interquartile range, or we'll just stick to writing IQR, is the range between the quartiles. So your biggest quartile, Q3, take away your lowest quartile, Q1. So that is our formula to find the interquartile range. So make sure that you take a note of this somewhere because we're going to be coming back to it quite a lot. You might be wondering why we would use the interquartile range or what it could tell us about a set of data. So the interquartile range is another measure of spread, just like the range that you worked out when we were working out the mean, median, the mode in the range. So it tells us how varied the numbers in a data set are. If we have a higher interquartile range, then that means the numbers are more spread out or more varied, and a smaller interquartile range tells us that the numbers are closer together or a bit more consistent. And the reason that we would use this value over just the normal range that we've worked out before is that the interquartile range excludes outliers, so any numbers that don't really fit in with the data set. If we look at this set of data here, the yellow data, I've marked on quartiles 1, 2 and 3. So Q1 is 15, Q2 our median is 19 and Q3 is 24. If we were to work out the range for this data, it would be the biggest number take away the lowest number. So 25 take away 0 is 25. But that doesn't really explain the majority of our data because the majority of our data lies in this range here. So if we work out the interquartile range, which is Q3 minus Q1, we get 24 minus 15, which is 9. So you can see how the interquartile range is smaller because it excludes these outliers, the 25 and the 0, that don't really fit in with our data set. Another value that you can be asked to calculate is the semi-interquartile range. So we should already know that semi means half if we think about a semicircle. So if semi means half, then the semi-interquartile range, so SIQR instead of IQR, is Q3 minus Q1 over 2. The semi-interquartile range is also unaffected by any outliers in the data, so any numbers, really extreme values that are either extremely small or extremely large that might skew your results otherwise. So the semi-interquartile range isn't affected by these big outliers, and that's why we would use it. For this example, we're going to find the three quartiles, so Q1, Q2 and Q3, the interquartile range and the semi-interquartile range. We have 10 numbers here, so our median is going to be in between our 5th and 6th number. So 1, 2, 3, 4, 5, and it's going to be in between this 17 and 17 here. So if we mark on that this is Q2, and Q2 is going to be in between 17 and 17, which is just 17. Then for quartile 1, our lower quartile, it will be the median or the midpoint of this section here, which is 16. So Q1 is 16, and similarly up at the top end for our upper quartile, Q3 is going to be 23. Now for the interquartile range, we know that the formula to find the interquartile range is Q3 take away Q1. Q3 is 23, Q1 is 16, so our interquartile range is 7. And the semi-interquartile range, which is Q3 minus Q1, so the range of the quartiles over 2. We already know that Q3 take away Q1 is 7, and 7 over 2 is 3.5. If we compare our interquartile range here, which is 7, with what the range would be for this data set, so the highest take away the lowest, it would be 46 take away 3, which is 43. So a huge difference between the interquartile range and the range, because this 46 and 3 are both outliers, whereas the rest of our data falls quite neatly close together. So that's why our interquartile range, if we have a data set that's got these outliers, would be a better representation of the spread in the data than just the normal range.